All right, so let's finish up these slides. We talked about social media, we talked about Python, and now I want to talk about technology in general, I guess. How can we evaluate it? How can we keep it nice and controlled? Because it's getting out of hand maybe with the advent of AI. Who knows? Might have to update these slides. So just like we love technology, like I'm obviously very biased, right, as a computer science instructor, but there are downsides to technology at the same time. Like we've talked about some of them. Let's learn how we can cope with those downsides and just be good citizens of the digital world. All right, think critically. So deepfake, I guess, is like one of the first big things that AI made mainstream, like the idea of being able to change a video super easily, right? So that's kind of cool. So the idea of a deepfake is when you use some sort of machine learning, so artificial intelligence, that's what that is, to swap the faces in a video, which is crazy. And so all the people on the internet, they wanted to make it a meme, and so they made for a few months, they made everybody into Nicolas Cage for fun, if you remember that. But yeah, that's something that is relatively recent, right? And we used to be able to trust videos, right? We could never trust digital images or even normal images from film because of Photoshop, right? Photoshop was a big deal. It's been around for decades now. It was very, very easy to always change an image. You can swap faces very easily in an image. That's been very easy to do for a long time. But a video, right, like a security camera video, used to be very, very good proof that somebody was in a certain spot and they did something, right? But now, with this, you can't even trust a video anymore, which is wild to think about. And so you can use this, and it's been used, especially politically as well, for fraud, hoaxes, and just for memes. And I guess that's the best use of it, maybe. But yeah, now you can trick people into thinking that somebody was somewhere, and they said they can also change their voice around too, right? You can pretend that you're somebody's voice, and that can trick a lot of people these days. That's a thing. So that's unfortunate. Have we seen any of that on the internet? It's crazy, right? So that's the thing. There's also the beautiful website that is Wikipedia, right? It has a wealth of knowledge for us. It's one of the greatest sources of information in our era. And the reason for that is that anybody can look at Wikipedia and see that it's missing something, and they can add a new article for that new thing that just came out. Or they can update an article on a person when a story broke about them, something like that. So the information that was there yesterday might not be the same that you see today because it might have been changed or added to, which is really cool. And so it changes as fast as information can flow, which is amazing. And so Wikipedia is lovely for that reason. All right, it's the ultimate news article, every Wikipedia page. But that's also a downside, right? Anybody can modify a Wikipedia article, which is good sometimes when you notice a typo. I fixed several typos on Wikipedia, but anybody can change stuff, which is both good and bad. You can edit the article that you see, and you can add weird or incorrect information. All right, let's draw some pictures of fake Wikipedia articles after I fix my pens here. So yeah, maybe you had a little article before. It's got a picture and some words. You can go and you can add a whole paragraph when something new comes out. You can also lie. You can go to the Clovis Community College Wikipedia page. I assume we have one, right? And you can change the picture of the campus to a picture of your cat. Okay, that's something that you can do. You can do that kind of thing on Wikipedia, and sometimes you can get away with it. You can also change text information in a subtle way that is not true, and still you can sometimes get away with it. So a lot of the time, though, Wikipedia is good at discovering that you did something wrong. It's kind of obvious sometimes to see that somebody vandalized a page, but a lot of the time it takes a human to come along later and get rid of the thing. All right, you may have seen citation needed on some pages that are especially controversial pages on Wikipedia, and that's just saying that somebody wrote a sentence that is still widely believed, so they didn't get rid of that sentence, but there's no good source for it yet. And so somebody needs to cite a source to make the article stronger. Okay, and so that is an issue with Wikipedia. Right? Hopefully your English professors have yelled at you enough about that already, but we still love it, right? We're not going to not use it, but We just have to think critically as we are reading Wikipedia, right? As long as you like go to the articles that Wikipedia cites, right? Actually visit those. Do your own research. Don't just like copy whatever they're saying. Then Wikipedia is a beautiful source. Okay, so there's that. So the Wikipedia is wonderful, and it also has downsides for the exact same reason, because anybody can update it. And so I was like on Reddit a couple years ago, and for some reason there was a link to the page for the California grizzly bear, and I read it for some reason. Like you see, like the very first line says Trump 2024. Like somebody analyzed the page, like for a split second that was there, and like maybe you've seen that before. That's a thing. That is totally a normal thing that happens, and sometimes it takes a human to go in and get rid of it. All right, so that's unfortunate, but it happens. All right, so yeah. Still use Wikipedia though. What else? Oh, this is a cool idea from your book. We, as a society, trust computers a lot. All right. We trust it so much that we simulate the way that a car might crash in only software, which is wild. Eventually, you have to actually do a real car crash test, but it costs money to do that, right? So, like every car that's going to be sold in America, apparently, you have to send it flying into a wall. Did we know this? Just to like prove that it's going to do good things and not hurt anybody too badly. So here's my example car, and they put like a little crash test dummy in it, right? You've seen these. That's a fun sound. And like you send it flying into a wall, and you make sure that like the car doesn't do something horrible, like it doesn't split in half and like horribly hurt the person that's in it, right? The crash test dummy has like some sensors on it. But it's very expensive to like waste, like you have to like sacrifice a car and a dummy and all these sensors, don't you? So wouldn't it be nice if we did this all in software? And that's something that people do these days. So they send this into a computer instead, and they virtualize like what the car looks like, how it's arranged with all the metal pieces and all that. They put it inside of your laptop, and you can run a bunch of different car crash tests on different models of cars that way. All right. So why not do it in software for free? There are some upsides and downsides to this. Again, there's a give and take, and I want you to think about it, right? Do you trust the software model of a car? Because what you have to do is that's really hard to think when I hear that. Sorry. What you have to do when you're modeling a car crash test is like you have to put a car in a computer. You have to have a 3D model of that car, and you have to program the physics, right? You have to program the physics of how the metal is going to bend, which is really, really hard. Okay, that's really hard to get accurate. We do know a lot about physics. You've probably been forced to take a physics class by now, depending on your major. But like we can't shove like atom level information inside of a computer. We don't have that much processing power. So you are making some generalizations inside of software. You cannot model each individual metal atom in the car. All right. So there you have to simplify things. And the question is, that's an ethical problem now, isn't it? Because your car crash tests inside the computer might not be perfectly accurate. They might not actually tell you the results that you would have gotten had you made a real car and flown it into a wall. See that? And you might have made the car less safe because of it. That's interesting to think about. Okay, so that's an ethical dilemma, and there are flip sides to every like there's a pro side and there's a con side, right? So like an argument for these simulated car crash tests is like eventually they're going to be forced to actually make a real car once they decide on the final layout of it, and they will have to do a real car crash test. So in theory, because they're running all these simulations, they can like iterate faster and get a good design that the simulation agrees with, and maybe it'll be safer overall because of that, right? So that's one thought, right? Eventually they're going to perform a real car crash test to let them do it in the software so they can like try a bunch of things, and maybe they'll get at something that they wouldn't have gotten at had they had to spend a bunch of money making cars and crashing them, right? But there's also a counter argument to that, because like what if the software wasn't good enough, and like if they just did a few more real car crash tests, they could have found a much safer model. So that is definitely an ethical dilemma, and yeah, what do you guys think? What are your thoughts? Are you pro car crash simulations? You guys might be biased too if you're computer science majors, like your future depends on having simulations maybe. So that's a thing. What else? A lot of us have smartphones, right? Most of us. and either, like, usually it's Android versus iOS these days, yeah. So Google, who makes Android, they can remotely delete an app from your phone. Did you know that? That's another thing that was from your book. I assume they still have this power. So they can take stuff off of your Android phone, and the reason they have this power in the Play Store or whatever is so that they can protect against bad people, right? People that somehow get their bad app on the store and people download it, and then Google notices, oh no, this is horrible, it has a virus in it, let's wipe it from everybody's phone. So they have that ability for that reason. But the second you give yourself that ability, it has the potential to be misused, right? So, like, that's another ethical question. Should the maker of your phone's operating system have control over the things that you put on your phone? So they can potentially get rid of stuff. Interesting, right? Interesting thought. So Apple also has the same ability. They've also done this kind of thing. So remember back in the day, I think it's still not there, right? There was some controversy over the game Fortnite on iOS. Have we heard about that? It's been like a year or two by now. But they got rid of it from the Apple App Store because Apple wanted like a cut of the money that the Fortnite people made as they were selling their subscriptions or whatever inside of the app. And they didn't like that. They thought that that was silly. And so they didn't give Apple the cut, and so they just like took them off of the App Store, which is wild to think about. I think they're back on it, at least in the European Union, because some laws have changed there at least. But I don't know if they're back on in the U.S. at least. I don't. Yeah, they won. So are they back on them? Oh, nice. Okay, I'll have to update these slides. Yeah, it's taken a while in that case because it's been out there. But that's good. That's good to know. It's like the argument is like the maker of the app store is like it holds a monopoly kind of thing over the makers of the apps, and like a 30% cut is not a small amount. So that's crazy to think about, that you have that kind of control. And yeah, the reason that's like very controversial is that like there's only one app store for iOS. First of all, there's multiple for Android at least, but there's only one for iOS. So to have that kind of control and that power maybe is too much power. All right, so it's another ethical dilemma. And yeah, if you don't follow the rules, like Fortnite didn't, they purposely broke the rules so they can sue Apple, or be sued and potentially win. Yeah, if you don't follow those rules, they're going to remove your app. So that's the thing. Apple and Google have the ability to get rid of apps on your phone. It's a slippery slope, though. What if you like install an app that they don't like? That's still normal. So interesting things to think about. And then one last fun fact that your book also talks about. I love this anecdote. So Amazon makes Kindle e-readers, right? So you can read books. And they accidentally, but they still did it, they accidentally removed copies of the book 1984 from their customers' Kindles, which, if you've read the book, that's like the ultimate level of irony. It's hilarious. So yeah, just to have that ability as the maker of some product might be a little too much. And so that's something for you to think about. So yeah, maybe we should make new laws. We should pass new laws about these things to either give people more power or less power. Depends on your thoughts. Okay. There's also the idea of, along those lines, like getting rid of a piece of software, making sure that you're always on the most recent version of a software. So forced upgrading is a thing. If we use, for CSCI, use Discord in this class, if you use it on your computers, right, it's going to auto-update itself before you can even use Discord. So Discord is forcing an update or an upgrade upon you always, but you can also do that in, like if you make an operating system. So like Windows, they force upgraded all the Windows 8 users to Windows 10. If you remember the controversy there. They also kind of did the same thing from Windows 10 to Windows 11, didn't they? So I fell for it. But yeah, that just poses the question now, like, do we have control over, like, no, we don't have control over our phones now, but do we even have control over what's on our computer even? So that's crazy. People are being forced to upgrade things, and maybe they like the old version, right? So again, an ethical dilemma. Should it be allowed to, like, force a change upon somebody? Okay. And so again, there's a flip side. Two sides to every coin here. So arguments for forcing upgrades upon people is like, just imagine your grandparents or somebody who's not super good with a computer, like running Windows. usually. And the reason most things get new versions is that there are bugs that can be exploited, and it makes it easy to hack, especially in an operating system like Windows. So older versions of Windows can be more easily exploited because Microsoft isn't like, they expect everybody to be on the most recent one, right? And so they don't really care about the people who didn't upgrade. And so it would be nice, like that's an argument for forced upgrades, because now people can, like your old grandparents, they don't have to worry, and it's like you can always expect them to be safe because of that. Like Windows is going to update itself. But on the flip side, like you lose control as the buyer of this software, right? You purchase this particular version. Maybe they messed with some feature that you really loved. Maybe they got rid of it in the upgraded version, and like if they force that upon you, now you're unhappy. Yeah. So that's an issue. So again, just a bunch of ideas that should hopefully get you thinking about different thoughts. All right, different ideas to have you critically think about. All right, about them. So yeah, I have just 2 more slides for this set of slides, and then we'll switch gears. But let's see, the last main slide I want to give you is the idea of equity. Do we know the difference between equity and equality, first of all? Have we been taught the difference? So like equality, like everybody uses this picture to teach it. I mean, it's definitely, the idea is more subtle than this, but like equality is giving everybody the same box to stand on, but still some people can't really see the game very well. But equity is like making sure that everybody gets what they need to be on the same level with each other, right? So like the school here, they give you guys like laptops and calculators to check out if you don't have one. And so that's the idea of equity. I give some of my students who work more time to do things because their jobs are taking up some of their time. And so that's the idea of equity versus equality, right? We don't have the same due date in this class for that reason. So yeah, equity is a big deal when technology is a big deal, and it is in our lives. Yeah, because just think about it. Like even if you want to get a job these days, you need like a LinkedIn account, you need an email, you need a cell phone, and like all those things cost money, right? Internet connections usually cost money if you're not at school and you can't like check out a router from the library. So like a lot of low income households, they don't have the technology that's like necessary to succeed in the world right now. And that's really unfortunate. Like that would help them like get out of poverty potentially. Like if you don't have a cell phone because you can't pay your bill, like, or an email address, like nobody's going to interview you because that's how they're going to contact you, right? That's crazy to think about. That's unfortunate. And like during the pandemic, that may or may not still be going on. Like everybody was forced to, like we're all doing online classes, a lot of us now. Like if you don't have a webcam, like for like a math class that's online, like you have to use that weird Proctorio software or whatever it is these days, right, to take your test. If you don't have one of those, you can't do it. You can't take the class. So that's crazy and unfortunate. So we should be thinking about equity. So when you guys become software engineers and you move up the ranks and become CEOs of all your companies that you work at, please think about this. All right. And the last thing I want to say is it's an unfortunate fact that a lot of the time, at a lot of software companies, there's not a lot of diversity, unfortunately, and obviously we're trying to change that with the CSCI 1 class and things like that. But a huge issue is that programs that people have made to do something are tested only on like the developers, like they're the people that are working at the software company, and that might not be a very diverse crowd. So like maybe the product is only tested on white people, which is very unfortunate. Right? So like that means even if somebody gets this cool piece of technology, it might not even work for them. And here's a good example of that. If you just read this tweet from the pandemic for somebody trying to take an exam using a Proctor kind of software, like they couldn't. It thought that their lights were off in their room when really they just weren't white. And it's really disgusting. Okay, so make sure to keep this in mind when you guys work at software companies. All right. Any questions, ideas, thoughts about this idea, about this stuff? Want to be able to rein in technology. Maybe we should become lawmakers as well and make some nice laws that help this kind of stuff. Okay? But if we are happy, I would like to switch gears to a completely different set of slides. All right. So I need to remember to save this as a PDF still. So that one. let's now go to this one. So along the same lines of bad things on the internet, let's talk about horrible things that have happened in the software era, right? In the software realm, risks and bugs that have to do with computers. So let's talk about them. There's a lot of things that have gone wrong over the years. Okay, and I'm forcing you to read about one in one of your essays, right? So, all right. So I'll try to answer this question. Like, how we love computers. I'm biased. You're probably biased too. Or we want to keep them in our lives, but why do we keep using them if they have so many issues, right? How can we reconcile that fact? Okay. So let me talk about a rocket. It's called Ariane 5, and this is a great example of a software bug that went wrong. Okay. So Ariane 5 is a rocket. This was it before they launched it. It was made by not NASA. If I zoom in here, not NASA, but ESA, which is cute, European Space Agency. All right, so they have one just like us, and they made a rocket. Ariane 5 implies the existence of Ariane 4, and that's going to be something that was part of the issue. And they first launched it, when they first launched the first version of it, it did not go well for them. Right? They lost a lot of money very quickly. So it self-destructed mid-flight on June 4th, right, 1996. So almost like 3 decades ago, right? And it only lasted 37 seconds into flight. And then it's just like it decided, you know what, I need to blow myself up right now. Something's wrong in the software. And so like there was a fail-safe so that it doesn't like crash land on Earth. It blew itself up because it thought something went horribly wrong. And the cause was an issue in the software. So in the blink of an eye, 1996 money, almost $500 million was lost, which is a whole lot more if you adjust for inflation these days. Isn't that crazy? Just a software bug. The rocket thought that there was something wrong, and it blew itself up because of that, but there actually wasn't something wrong other than an issue with the software. Crazy. So, yeah, unfortunately, they lost a lot of money very quickly just due to something that could have been prevented in code. Okay? So let's talk about it. Let's talk about the issue, and I can do my best to explain it. All right? And I think you'll be able to understand it. So what they did in Ariane 5 is they tried to take a 64-bit float number. Remember what those are in Python? Float means it has decimals. So like here's the float type in Python. And it would appear that my pen is bad here too. Oh, suddenly fixed itself. All right. So remember the float type in Python? It's the cloud. What are things that can be floats? Things with decimal places like 3.14, and like you can even like get some really big numbers in the float type. You can use scientific notation like 5 times 10 to the 50, and they were using 64 bits to store that number. So what that means is it's like 64 ones and zeros. So what they did was they tried to take a 64-bit float and they tried to shove it into a 16-bit int. Okay, that's what they did. So you understand those words, but I'm gonna do my best to like explain what they all mean together. Okay, so float is this. What is int, right? Do you remember what int is? Int's just whole numbers. So we lost decimal places, and we don't get numbers that large either, right? So int can be 0, 42, negative 42, no decimal places. You can only get so large, especially when it's 16 bits. And so what they tried to do is take a 64-bit float that had the potential to represent large numbers, like 64 ones and zeros to represent large numbers. 64 binary digits, bits, right? They tried to take that, like it was a number from a sensor in the rocket, and they tried to shove it into 16 bits as a whole number. Like maybe they tried to round it or something, I don't know. But 16 bits is a quarter the size of 64, yes? So that's unfortunate. They thought it was going to fit, and it just didn't work out, all right? So, yeah, that's what they did. Hopefully you can see the potential for issue there. And that special number was the horizontal velocity of the rocket, all right? And I don't actually remember exactly what that means, but here's my best guess. Like here's my best drawing of Europe. There's Italy. There's like the UK and Ireland. They're blasting off this rocket, right? Whee! And I imagine that horizontal velocity means the speed relative to like this way on Earth, like maybe west or something, west or east. That sort of velocity versus like relative to a spot on Earth. That's my guess, right? And so it's like a speed number, and yeah, that horizontal velocity number got so big that it couldn't be shoved into 16 bits. Okay, that's what happened. There was not enough room to store that converted number, and we say that it overflowed because, like, imagine like you're pouring water into 16 bits and like there's no extra room because you had like 64 ones and zeros. Like this is too small of a bucket for that. Yeah, that's kind of the idea. That's why we call it that. But that's what happened. They tried to take a large number. Unfortunately, it could not be stored, and so the number was a bad number at that point. Because just imagine like you were using 4-bit numbers to store something. What are your 4-bit numbers? 0, 0, 0, 0, all the way to 1, 1, 1, 1 base 2. Yeah. So what happens if you only have 4 bits to store something, and like you're already at the biggest number, 1, 1, 1, 1, base 2, and you try to add like one more to that. Like, okay, it's a little bit bigger. We went a little bit faster. But you only got 4 bits to store the information. Let's do binary math right now. All right. So what's 1 plus 1 in binary? It's still 2. But what is 2 in binary? It's 1, 0. Yeah, 1, 0. So you actually have to carry a whole lot more often when you're doing addition in binary. So there's 1, 0 there. And now it's also 1 plus 1, which is 2. So 1, 0, carry the 1. 1, 0. Again, 1 plus 1, 1, 0, carry the 1. And here, the very last digit, 1 plus 1, it's again 1, 0, carry the 1. So it's carry the 1, 1, 0. And we only have 4 bits, though, so we're like, the answer is supposed to be this, right? 1 with 4 zeros. We only got 4 bits, so like, we just throw that one out. And so you thought, like, you try to add 1 to the largest number, you got 0. So the rocket kind of thought that it's not moving very fast. Maybe the rocket engine failed, kind of thing. Something like that. All right, do we see the problem? So that's an issue. That's called overflow. And the reason this happened is because they were lazy. They reused, this was Ariane 5, they reused their old code from Ariane 4, and the makers of the Ariane 4 rocket, they're like, this thing's too small, it's not going to go that fast, like, the horizontal velocity is not going to be ever above something that we can represent in 16 bits, so we're good. And so, yeah, they thought that would be true too in Ariane 5, but apparently Ariane 5 was a lot faster. Or they shot it off at a different angle relative to Earth or something. So that was the issue. If only they just used a little bit more space, surely they had a little bit more, they could have solved this problem. Right? So this was like, you can imagine this is like one line of code, honestly. Just like keep it afloat or something. They could have fixed this by changing one line of code. Isn't that crazy? And they lost almost $500 million in 1996 money. Very unfortunate. So yeah, this kind of motivates the idea of like, if you're making rocket software, we should be really confident that it's going to work. Yeah, or like airplane software. So try to think about it like in your minds right now. How would you solve this problem? How would you make sure this never happened? All right. Well, I'll explain some more things. Okay. Another idea, of course, as we're getting close to a major election year, this is more important than ever. So voting systems can be electronic. In several states they are. I don't think we'd have any electronic voting in California, right? It's all paper-based these days. Pretty sure, at least. But here's another fun story from your book. Back in the day, I forget which election, but some electronic voting systems during an election year, they ended up crashing. And all the voters that, like, there was no mail-in ballots maybe for that county or whatever, they tried to come in and vote, but they were turned away because they could only vote with that system. That voters were unable to vote. Crazy. So that's unfortunate. We don't like that. All right. Surely, hopefully they started using paper and they somehow made it work. But that's a problem. Like, if you have things that are electronic, they can mess up and you have to have fail-safe somehow. Another county lost like a few thousand votes, which depending on which election it is, maybe it was like a election for just the county, like the mayor or something. Like they lost a significant number of votes potentially because the memory of the voting machine just got full and it didn't alert the people in time. That's unfortunate, right? That's crazy. We don't like that. So how would we fix this? Like, we have to think about this. Like, how would you display the error on the screen in a way that somebody would understand? So they can go like save it, like write it to something so they can fill up the memory with some more votes. In Texas, one year, in a county, they were using an electronic voting system, and there was a bug in the voting system, and that generated 100,000, which is a very big number, right? Extra votes for a candidate. Luckily, they caught it. Like, maybe that was more than the population of the county, but like, imagine if they didn't, right? You can have these problems now that electronics are in the mix, now that software is in the mix. You can just have a bug, and it can affect who gets elected. That's really, really wild, all right? And then one last bug is there was one that caused, this is kind of the worst one, it caused some candidates to receive the votes that somebody else had cast for somebody else. So, like, you choose person A, and it's really going to cast a vote for person B. That's the worst one, I think. That's a horrible bug. It's like not counting towards the person you actually wanted to vote for. And hopefully, luckily, like, this is in the book, so they noticed it and they fixed it. But just imagine, like, maybe there was a year and a certain voting system that they didn't notice it in, and like that affected something. So that's crazy. And like, we know, we've programmed, right? I forced you to program a lot in this class by now, and we know that it's really hard to write software that's right? It's not right the first time, most of the time. It's hard to write software that's correct, that's safe, that can't be tampered with. Like, all of these things are problems that we somehow have to fix if we're going to have like voting systems and rockets and airplanes and autopilot, right? So we're going to have to fix these things. I have some ideas, and I'll tell you about them, all right? But eventually, like, if you do it well enough and people like become confident enough in the system, like, it ends up working out in people's favor, right? So in like Estonia, which is a fun Baltic country, they all vote online, actually. They all trust it, and it all works out for them. So maybe we could have that one day. One day, right? But like, that's the thing. That's maybe a cultural difference. But there can be issues that we have to iron out. We have to have a way to make sure our software is correct. Okay? And so, yeah, here is the very important slide. Has to do with your essay, right? The essay that I gave you with the article to read about the Therac 25 machine. So if you haven't read it already, I'm going to give you a little sneak peek of that article. But the Therac 25 machine is probably the worst accident in computer science history, I would say. This rocket luckily had nobody in it. So I forgot to say that, sorry. Nobody died. It was just an unmanned rocket. People died with this thing, okay? The Therac 25 machine. It was for people with cancer. It was a radiation therapy machine, and it was computer controlled. It was software that was like shooting the radiation beam at a person, okay? And yeah, it was made in 1982. That was when it first came out, the Therac 25 machine. And the first documented accident with it happened in 1985, but the issue that I'm about to describe existed the second it came out. So like, there were many, many people that got affected by this, and they potentially ended up dying because of it. It's really, really unfortunate, very sad story. So there are errors in the machine, right? If you haven't read the article, go read it for sure before you write your essay. But what happens in a radiation therapy machine? I'm definitely not the right kind of doctor to explain this. But, like, you've got a little radiation gun that shoots radiation at like something that's cancerous in your body, okay? And the goal is to shoot the radiation in just the right amount that like upsets that little cancerous particle, the tumor, wherever it is, and that causes the cancer to die away, right? So unfortunately, there were some bugs in the Therac 25 machine. There was just part of the code ended up giving people up to 100 times the amount of radiation that was supposed to be like put into their cancerous part of their body, okay? And obviously that gives you more cancer. Radiation does that amount of it. And so these people who were trying to get their cancer cured, they ended up getting more cancer and dying. It's really, really sad and unfortunate. All right? So yeah, the issue, the bug, just in a nutshell, is like there was an old version of the machine, like the Therac 20 or something, I forget the number, but the old version of the machine, it had like a hardware system in place. Like there was a lead little beam, there was like a lead cylinder here that made sure that even if the software messed up, there would be no excess radiation. But they got rid of that in the Therac 25 model. They're like, oh, it seems to be working. Let's just make it for cheaper. Let's get rid of this. And so, like, accidentally, if you like program it in just the right way, and everybody was doing it that way, it ended up like shooting a little too much, way too much radiation into people, right? And so, like, they got rid of a hardware fail-safe because they thought they didn't need it, because the old machine worked, right? And they thought like it was never in use. So yeah, that is the story of the Therac 25 machine, and I'll be asking you definitely to write your essay on that. It's a very sad story, and it just again motivates the idea of like we need to, or if we have very safety critical things, pieces of software that we're writing, like a radiation therapy machine, like a rocket, like the autopilot in a plane, we have to be very, very confident that that software is going to do the right thing. Otherwise, people's lives are at stake. Okay, so that leads to a very sad story, leads to a very, very important little question for you guys. All right, so I would like you to get into little peer instruction groups as you do, please. Dun, dun, dun. And I'll stop attendance once you do it too. So please do attendance if you have not already. For some reason, it thinks I'm on the login page. I think it logged me out right now as I was taking attendance. That's funny. But it's still running. Like it figures itself out. But so do that if you haven't, but also go to the written ice page. That's funny. I'll clear it out for us. But here's your topic. I'm not going to give you like even or odd things. I want you to talk about both sides. So here's my question for you guys to discuss as a group. And you can pick a leader to write in your answer. But what do you think? Is it the programmer's fault when something goes wrong in software, like in this radiation therapy machine, and people end up getting hurt? Or in the rocket, like accidentally crash landed because the software was wrong, and like it crash landed into like a house. So like, is it the programmer's fault when something bad happens and human lives are at stake and people end up getting hurt? And so I want you to answer that yes and no. I want you to give a good answer to say like, yes, it is, and here's why. And also I want you to think about the opposite side of that. Like, I want you to come up with another good argument saying, no, actually, it's not the programmer's fault. And here's a good reason why. Okay, so I want you to try thinking in both ways this time. And yeah, do your best. Let me know if you have any questions, but this is a good discussion to have with all this new knowledge. Okay, nice. I heard some good words. Give me another couple minutes to discuss and think about both sides. Another minute or so. Was that enough time to get something in? Waiting on one group. I'll give you guys a couple. Another minute. You guys are just now typing. All right. This is an important topic. We shall discuss it when you're ready. You guys can just say it out loud if that's easier. Like, is it taking a long time to type? Is that the problem? Nice. Thank you. Let us see. Let us see what we think. Why might it be and why might it not be? So yeah, what do you guys say for it is the programmer's fault? So it is their fault and they should be held responsible because ultimately it was their job to ensure that it would function properly. That is true. That was a very good argument. Like, that's what they were employed to do. Surely, like, there should be some consequences, right? And then very good job, Group 49 as well. Like, more test cases, like something. We should have done something, like test it out and make sure that it was pretty good. Like, there should be something that we can point to and say, like, we tried at least, right? We tried really hard. Okay, and I doubt they even did that in this case for the Therac 25 machine. So good thoughts. And then what are some reasons why it might not be the programmer's fault? Let's think about it. Right? It's not their fault because, yeah, maybe it's the company's fault itself. That's a great way to pass the blame. Because, like, there should be maybe multiple people. It shouldn't just be, like, the buck shouldn't stop at just one person, right? Like that one programmer who was like being given 12 things to do and not enough time to do it in. There should be somebody else, like multiple people up the ranks, making sure that everything's working. So that's a great thought. And then, yeah, Group 49, very nice, because that's another good argument. Maybe it's not their fault because like they were just told to do something, and maybe the thing that they were told to do, like they did it well, but that thing that they were told was wrong, right? Yeah. Hmm. Yeah, a typo in the specification of the problem. Like I give you guys a problem document to do your assignment. Like they could have messed up that kind of document that they gave to their programmer, and like suddenly it's not their fault. So these are great thoughts. Good job. Very nice. Let's come back here. So yeah, I hope that was an interesting discussion. You can use this, of course, in your essay. Yay. But yeah, here's some of my thoughts. My best guesses. Like it's really hard to just like assign blame first of all, because I don't know how well you guys know the software industry, but like there's more than just one person working on software. Usually, like at a large company, there are multiple separate teams that don't really even talk to each other too much, all working on the same piece of software. So there can be a disconnect between what one team is thinking and what a different team is thinking, and like their stuff, their code is supposed to work well together, and it might not, right? So it's very possible that like the programmers down in the trenches, they have no clue about the big picture. They just like know about this little thing that they're asked to do, and they don't really even know how it's like eventually going to be used. So yeah, that's one reason why it might not be their fault. And yeah, also at the same time, just to be nice to them, it's like you all know how easy it is to mess up in your programs, right? It's not an easy thing to write software that's correct the first time, right? Even I mess up all the time in my classes, right? And I just fix it and move on. But like the goal is to like figure it out quickly that something's wrong. A lot of companies, they hire someone, like they hire software engineers just to test stuff. That is a big deal. So that's part of the solution. We should be testing our software all day long. There's another flip side of that called verification, which might seem like a synonym to you. I'll explain the difference. That there is a difference in computer science, at least. Testing and verification are the main ways to guarantee that our software is right. Okay, and yeah, there's a slight difference between these two words. I will teach you about testing today. Right. So how do we test code and make sure it's going to work? Right? You're kind of doing that informally as you're writing your code. When I give you a problem, you're trying to make sure it's working. But let's try and like spell out what does it mean to test code? Like what's a way that we can formally do that and everybody can agree on like what it means to test something, all right? So yeah, all a test is you have your code. Here's what it means to test something. Here's your code, or maybe even somebody else's code. Like you're asked to test somebody else's code and you don't really understand what's going on, but you know the problem itself. So you just think of the code as like a black box, your code. And what you do is you feed it inputs. So like you feed your code 42, for example, all right? And what you do is like you come up with the number 42 off the top of your head or something randomly, and you feed that into your code, and you're like, okay, what should happen in this code is blank. And like the answer that my code should spit out if I give it 42 should be like 13 or something. All right, that's what should be spat out. And then you go and you like plug it into your code and see like, oh, does it actually tell me 13 in the end? That's what it means to be a test. You come up with some examples and you make sure that what your code does matches your understanding of the problem and what should have happened. You compare what should have happened to what you got actually. Okay, that's the idea. And you just come up with a bunch of different test cases along these lines. Like now we'll test 43. Maybe what should happen is like it should give out like 14 or something, but it really gives out like 33, and like that's obviously wrong. So like we're always checking, like we're coming up with an example, we're running the code in our mind essentially, like what should have happened, and we're comparing what we see to what we expected to see. That's what it means to be a test in software. Okay, so yeah, this is one of the most common ways, the easiest way to catch a bug with your current level of knowledge. The testing is done very extensively in the software industry, and yeah, it's super easy. We just got to do it, right? Some people, a lot of people are lazy; they don't like to write their tests, but it's very, very important to write tests, especially when you're writing important software. Okay, so yeah, it's just an easy way to catch bugs. It does not catch every single bug. like the 42 test might skip over some important code or something, and like only the 43 test covers that code, or 42 does the other kind of other side of the code or something. Like there might be multiple ways that your program can run with a bunch of different like if-elses, right? So you have to like cover your entire code with many tests, and it's hard to come up with a good test suite of a bunch of test cases, but that's kind of the idea, right? So here's an example test, like just to spell out this idea. Here's what it means to write a test. Example test. I can't write an M today. Just like try input 42. And just like confirm the output was supposed to be 13. Right? Confirm that you actually got 13 out. Okay, that's all a test is. And so you just make a bunch of these, and the more you make, and the more different they are from each other, the way that they run the code in different ways, the more confident you can be that your code is correct. Right? A lot of people hate writing tests, though, and so that's one reason like they hire a separate person to do it a lot of the time. But hopefully, I have convinced you of their importance, and you'll be willing to write some tests one day. All right? So I just want to show you. Let's go back to Scratch. I lied and said we're done with Scratch. I have one last thing to do in Scratch because we need like ifs. I haven't taught you if-else in Python yet. So we need that to write a test, right? Because it's just like if the output was 13, then we were good, otherwise we're bad, kind of thing. So we can do more interesting things in Scratch right now anyway. So let's write a program, let's write a test for it, okay? So let's make this program. Let's make a new block called multiply the numbers from 1 to blank block, okay? Like 1 to 4, for example. And like the job of that is supposed to multiply 1 times 2 times 3 times 4. So it's kind of like a factorial kind of block. And so yeah, let's make that block, multiply the numbers from 1 to n, where like n is like a blank number that we give to the user, and so they can fill it in with different things. So let's first of all make it, and then let's also write some tests, because like what are some good tests for a block that works like that, right? So like what is 4? We feed in 4 as our input. What should it spit out to us? What is 4? 1 times 2 times 3 times 4? It's 24, right? That's a test, right? You feed in 4, we should expect to see 24. You feed in 2, we should expect to see 1 times 2, so still 2. You feed in 1 even, we should expect to see 1 times 1, still 1. Those are some good corner cases maybe. So let's talk about that. So let's write this block. I'll show it to you in Scratch. And we'll write some tests for it. And yeah, we'll go from there. So let's go back to Scratch for fun one last time. Or at least you can just watch me. So I'll give you this code, like I do. Whenever it decides to load this. There you go. There it goes. Okay. So we're in Scratch. I like to make a new block. Make a block called multiply the numbers from 1, 2. Then you can click this add an input thing. Add an input, and I'll call it n. Cool. I like it. So yeah, that's my block, and you can give it a little piece of input. We didn't do that last time. So that's one last thing that we can do, one last feature of Scratch that I haven't told you. And that makes a define thing, so you can say give meaning to this block, and we also have the block to use. Multiply the numbers from 1 to 4 or whatever, all right? It's like once we have this, we can run it a bunch of times. So that's the goal, that's how that works. And yeah. Now we just have to give meaning to that block. What does it mean if the user runs this block? Because they can have multiple of them, right? Oops, not a comment, but like what if they did 1 to 2? Like it should come, like what happens when you run a block is it jumps up to the define part and it starts running with whatever you gave it actually. So 4, 2, and it sees what you gave it. Like this time, if you run this one, it's going to see 4, and it's going to be placed in this thing that I called n. So like a special secret variable just for the define. It'll be set to whatever you just gave. So like if you run it with 4, this n thing will be set to 4. You can use that, just like an extra variable you can use. And then if you run it with this one, right, it's going to jump up here to the definition, and n will be set to 2. So you can use it, and it's different depending on how you just ran that block. That's kind of nice. It's a special variable that's getting set on the fly as you're running the block to whatever number you're placing here. Okay, so that's the goal. And so let me just quickly make the actual definition. Like, what does it mean to multiply them in? So we've got like a number variable. Multiply the numbers from 1 to 4, so like 4 can go in like a num variable. And we're going to make a product of numbers, right? So I'll make a product variable. Product. And the goal is I want to multiply like 4 into product, 3, 2, and 1 into product, right? I'll just go in reverse order because it's easier. I already have the 4 to work with. So that's what I'll do. And so product should start at 1, so I can keep on multiplying things into it, and it's a normal answer. It's not like scaled in any way. So I'll multiply 4 into num, make 4 3, multiply 3 into num, so multiply 4 into num, that makes product 4. 4 times 1 is 4. Then the next number I want to multiply in is 3, so make num 3, multiply it in to product, now it's 12. Then make num 2, multiply the 2 in, now it's 24. Make num 1, technically you don't have to multiply 1 in, but we'll do it anyway. Multiply that in, it's still 24, and then make it 0, and we definitely don't want to multiply 0 in, right? We're done by that point. So if it ever gets less than 1, we're done, all right? So that's the goal. Repeat until the number is less than 1, essentially. That's the goal, all right? So that's going to be my answer, and so I'm going to need some variables. This n variable is whatever I got from the user, just like that answer when you do like an ask block. This is unchangeable, so I need an extra variable. I need my product variable for sure. Product. And I also need, I'll call it num, like I did on the slide. I need a num variable as well. So I can take this n, whatever I gave it, like if we ran it with 4 or 2, it's like n will be 4 or 2. I want to shove that into a variable that I can control. All right, so I'll call that num. So the very first thing I want to do is set num to whatever this n was that I got from the user. So like if I ran this one, n would be 4. I got this one, n would be 2, and I'm shoving that into num so that I can run my block. And so you see it's going to be different every time. Like if I click this block, num is 4, if you can see that. If I click this block, it runs this again, and now num is 2. So like this thing is getting shoved into this special variable n, which I'm then shoving into num, because now I can mess with num. Okay? And then also at the start, product should be set to 1. So I set product to 1, and then we loop, right? We're going to repeat until, I'll just do it quickly, because the more important thing is the test. I'm going to repeat until the num variable is less than 1. The second it's less than 1, I'm done, like 0 or something. Repeat until num is less than 1. The following, where I multiply num into product, the current one, like 4. Product becomes product times num, the old value, and then after I've done that, make it 3, right? Make it smaller, make num 1 smaller, because that's the next number I want to multiply in the next round of the loop, right? So set product to be itself times its old value times num. So it's like the current value times like the 4 times the 3 or whatever. And then the next round of the loop, I want to multiply 3 in or 2 in or whatever, the next smaller number. So num needs to be changed. I'll change num by -1. So that should do it. Then we can have the scratch cat like say out the answer, and the answer is going to be in the product variable, 24 or whatever. So we'll have the scratch cat shout out the answer. Say product for 2 seconds. So like that's going to be the code, and it'll work. Like we get 24 for that one, and we get what? 2 for that one, and those are the right answers. And so this is the code, and we want to just be confident now that it's correct. Okay. So we're going to make a bunch of test cases. So in Scratch at least, because we're saying the answer, can't really like have an if statement or not an if statement, an if block. But we want to test like corner cases. We want to test like normal numbers like 4. We also want to test corner or edge cases. Right? That's where things or like inputs are almost correct or almost not correct. When you have loops involved, like make some code that's going to run loop just once or something, or make some code that's going to skip the loop entirely. Okay. So like that means some good corner cases for us are like when n is exactly 1. So that means it'll run this loop exactly once because num is 1, still not less than 1, but then it'll become 0 and stop. So like make sure it'll work if it only runs once. Make sure it'll work if it runs not at all. So like setting n to 0, trying it with 0 is another good test case. Okay. And then like a couple times, 2 or 4 or whatever. Okay. So like those are some test cases, and like here's the scratch version of a test case. Just like add a comment being like, this should be what? Should be 24. This one should be 2. And that's us, right? That's what we're doing. We're running the code in our mind. This is what the answer should be. Do we see that when we try it? Click it. Yeah. And we'll just duplicate that a bunch of times, right? We'll try our edge cases. We'll do 1 to 0. Multiply all the numbers from 1 to 0. There are no numbers. So like, what should the answer be? By default, I think the answer is going to be 1. Maybe that's not good, right? And like, while we're thinking of test cases, like maybe we're thinking of like, that helps you think about the real implementation, doesn't it? It's like, okay, if we get numbers in reverse order like this, like where the original number is even smaller than 1, like it doesn't even make sense to multiply those numbers. So maybe we should like give an error. Should, I don't know, result in an error message. Something like that, right? And that's giving us new things to program. That's helping us thinking of these tests. So yeah, we can go in and we can add that in real quick and be like, all right, if oops, I just attach that to the test. I need an if real quick, and I think I need to, let me zoom out and move stuff over. Go over there, tests. So yeah, we noticed that, okay, number is smaller than 0, and num number is smaller than 0. That's a problem. So if either n or num, because I just put n into num here, either one. If either one is smaller than 1, we'll just do n again. Why not? Then we can shout at the user and say, you know, invalid inputs. Something like that. And that's helping us. It's helping us write a more correct program. And then obviously we want to stop. We don't want to continue here. So we'll do the stop block. Just like that. But otherwise, if we didn't stop, we didn't hit this one, just keep continuing and do the rest of your work. And so here are our tests again. It's still 24 for that one. It's still 2 for that one. And now this one should have been an error message. Now it says invalid input. And now it's more correct. Yeah, that's good. Thinking of these tests like that. You should also test very, very incorrect cases like -42. And that should also be an error message, right? So again, we're running the code in our mind, being like, what do we expect to see here? Do we actually see that when we finally run it? So that's the trick. All right, and then you do some normal ones like we already did 4. I'm confident that 8's fine, so we don't have to do that one. But that's kind of the strategy, okay? Do you see how like you want to test your code? Like it's not good enough to stop with like 4 and 2, because then once you have this, you'll never hit this if anymore. See that? You don't even know what's going to happen if this part's going to do it right. So you need to give something that's going to like run the body of this if as well. Okay. So that's kind of the strategy game. And then once you have these kinds of ones, enough of these tests, you can be pretty confident, okay, I'm pretty confident that's going to work right when it loops a bunch of times, loops a few times, loops no times at all. And when we get invalid input, it tells me, it yells at the user. All right? So yeah, that can help you be very confident that your code is correct. It's always the game that you're playing when you're making a test is you're comparing what you got back from your actual code running with what you expected to see. You're running that code in your mind, and you're seeing, did it do that right thing? Okay, did it do what I expected to see there? Okay, so yeah, that's testing in a nutshell. And like, if you do this a lot, your programs will be closer to being perfect. All right. So that I think is where I want to stop for the day. Are there any questions about any of that? Fun ideas. Very sad stories, though, unfortunately. But we got to tell them so that we don't make those mistakes again. And I think that's all that I wanted to release as well. So yeah, just the lecture for the day. I'll give you plenty of new assignments next week, but that will be a problem for them.